Welcome to Space to Ground. I'm Jane Jennings.
And I'm Wynn Scott. 1 month ago, NASA's SpaceX 30-second commercial resupply mission launched from the east coast of Florida to the International Space Station, carrying approximately 6,700 pounds of cargo to the orbiting laboratory.
And that Cargo Dragon spacecraft will soon complete its latest mission when it undocks from the space station before splashing down off the west coast of California. One of the investigations returning on Cargo Dragon is called rhodium euthyphonate. Most plants on Earth grow by producing their own food using sunlight, water, and carbon dioxide in a process called photosynthesis. But what if plants could grow without depending entirely on that process? NASA's rhodium euthyphonate investigation is exploring just that. The study, developed in collaboration with the U.S. Air Force Academy, is testing how plants respond when they're provided with nutrition from an external source instead of relying solely on photosynthesis. Using genetically modified dwarf tomatoes, researchers are supplying acetate, a supplemental nutrient in place of carbon dioxide. Pre-flight testing shows that this approach could quadruple plant yields, even when photosynthesis is limited. The experiment will compare how these tomatoes grow in space under low light conditions versus on Earth. Scientists will also study how this new method affects development and gene expression. The results could pave the way for more reliable food production during long-duration space missions and have important applications here on Earth, especially for indoor farming in cities and regions affected by climate change.
As we look ahead to future space voyages to the moon and beyond, scientists are studying alternative protein sources created from microalgae. Ice cream, yes, ice cream is one of many products made with a protein powder created from microalgae by researchers for the Sofonster investigation, which looks at whether the stress of microgravity affects the algae's protein yield. Results could provide insights into cell growth, metabolism, and protein production by these microalgae under microgravity conditions. Microalgae are nutrient-dense and produce proteins with essential amino acids, beneficial fatty acids, B vitamins, iron, and fiber. These organisms also can be used to make fuel, cooking oil, medications, and materials. Learning more about microalgae growth and protein production in space could provide a food source on future space voyages and also has benefits for those of us on Earth. Microalgae has potential in the production of alternative dairy and meat products for consumption on Earth, as well as biofuels, biomaterials, and bioactive compounds. You can keep up with the current crew on station as well as the science by following us on social media at NASA_astronauts, at space_station, and at ISS_research.
And that's Space to Ground for now. Thank you so much for watching.